So anyone who remembers chemistry from some other point in life might be saying through all of this, you are taking a really long time to do something simple. All you do is cross and drop. So you take this and it's like a 1 there, and this one, that's where this one goes, and then this one goes over here and it's like a 1 here. So you end up with, and you kind of don't worry about the signs, so you end up with an assumed, because remember we don't write the ones, but an assumed 1 to 1, like Na1Cl1. So that's all fine and good. We're going to do a few more just to remind you, yeah, you can make this work most of the time. So over here we have the 3. We're going to cross it down, so that's a 3. The 2 will cross over this way, so you end up with Ca3P2. And then over here, the 2 goes over, the 3 goes over, so you end up with Al2O3. All right, so here's where you have to be super careful. When you're doing these, it has to be, for the cross and drop to work, it has to be the lowest ratio. And it's not going to work if it's not the lowest ratio. So if you look right in this situation, I don't have the lowest ratio. So I would not say Ca2O2. You can't do that. It's got to be the lowest ratio of the charges. So this is kind of like being +1 -1. That's kind of weird though, because it isn't +1 or -1, but it becomes Ca understood 1, understood 1. And another example of this is here. This is not SN2O4. See, those aren't the lowest ratios. We're all about low ratios here in chemistry. So you would have to like simplify kind of like that and make it SnO2. Of course, remember these are not real charges. It's just a little trick that we're doing, kind of trying to show how you can do this a little bit more, just with a little bit less thinking, I guess is the way to think of it.